Good morning, everybody. Today we are going to the topic Newton-Raphson method, department Agriculture and Food Technology, subject Statistics and Numerical Methods. I am myself. I am K. Palanivel, SNS College of Technology, Coimbatore. Title of the case study: a case study on optimum power flow analysis by Newton-Raphson method. First of all, going to abstract. An optimal power flow OPF, optimal power flow is a critical control task for reliable and efficient operation of power grids. OPF studies to minimize both the power distribution losses and the cost of power drawn from the substation without affecting on the voltage regulation. This case study discusses the Newton-Raphson method that can use us with OPF control for the stability of the power systems. This case study has a faster solution for load flow analysis with the condition and work well for heavily load system when compared to another method. The expected results for load flow are voltage magnitude, phase angle, real and reactive power. This power simulates the Newton-Raphson method for an optimal load flow analysis with buses. Next, going to the introduction. The advanced development of power grid system for future will give immediate impacts of a new connection such as power flow direction, production, voltage, profile, power quality and stability. The demand power, the electrical grid extended and classified the generation, transmission and distribution. This extension required to increase the transmission voltage that reached now 1200 kV. So the electric networks become more complex. That's in a case many problems in power flow control. Regarding this increasing, it's important to apply optimum plans for the power system to reach to minimum cost and without affecting the voltage in the system. The advanced development of power grid systems is future importance. The purpose of power flow studies is to plan ahead and account for various hypothetical situations. For example, if a transmission line is being taken offline for maintenance, can the remaining lines in the system handle the required loads without exceeding their rated values? Smart grid, considered as future electrical power generation, uses calculation tools, methods on flow of electricity and information to create a widely distributed automated energy delivery network. The concept is being widely accepted in power system today, and now it presents some big challenges in integrating generation with additional of a communication network in more efficiently. Optimal reactive power dispatch problem as a sub-problem of the OPF is a very important optimization problem in power system, as proper management of a reactive power injection into the system can minimize real power loss and voltage profile deviations and improve voltage stability. The algorithm for the power flow calculation based on the Newton's method in optimization allows to find a solution for the situation when initial date are outside the extents domain and to pull the power operation point onto the feasibility boundary by an optimal path. Also, it is possible to estimate a static stability margin by utilizing Newton's method in optimization. Next, we are going to active and reactive power calculations. The formulation of the active and reactive power entering a bus it's needed to define the quantities. Next, also assume the current entering a bus to be positive and that leaving the bus to be negative. Next, as a consequence, the power and reactive power entering a bus will also be assumed to be positive. Next, data for load flow. The active and reactive power generated at bus I be denoted by BGA or OGA, QGA respectively. The real and reactive power consumed at the bus PLI and QLI respectively. Also, the real and reactive power consumed at the ith bus by PL and QLI. Since the magnitudes of the voltage and their angles are not known a priori, an iterative procedure must be used to estimate the power voltages and their angles in order to calculate the mismatches. Now, estimate the bus voltages and their angles in order to calculate the mismatches. It is expected that mismatches del PA or del QA reduced with each iteration and the load flow is said to have converged when the mismatches of all the buses become less than a very small number. For the load flow studies, by consider the systems which has two generations and three load buses. We define bus 1 as the slack bus while taking bus 5 as the PV bus. Bus 2, 3, 4 and 5, 3, 4 are P and Q buses. The line impedances and the line charging admittances are given. Based on this date, Y bus matrices is given. The matrices is to be noted here. The sources and the internal impedances and are not considered while forming the Y-bus matrix for load flow studies which deal only with the bus voltages. Next, simulation of power flow by Newton-Raphson method. Let us assume the n bus power system contains total number of PQ buses while the number of PV buses NG such that n equal to NP plus NG plus 1. Bus 1 is assumed to be the slack bus. We shall further use the mismatch equations del P and del QA given in the respectively. The approach of the Newton-Raphson load flow is similar to that of solving a system of non-linear equations using the Newton-Raphson methods. At each iteration, we have to form a Jacobian matrix and solve for the corrections from an equation of the type as given. The Newton-Raphson procedure, the load flow algorithm is as follows. Step 1. Step 1. Choose the initial values of the voltage magnitudes Vi of all NB load buses and n-1 angles delta of 0 in the voltages all buses except the slack bus. Step 2. Use the estimated V of 0 and delta of 0 to calculate a total n-1 number of injected real power pascals and equal number of real power mismatch delta P of 0. Use the estimated V of 0 and delta of 0 to calculate the total NP number of injected reactive power Q calc and equal number of reactive power mismatches delta Q of 0. Use the estimated V of 0, determinant of 0, delta of 0 to formulate the Jacobian matrix J of 0. Solve for delta of del 0, del of 0 and delta V of 0 divided by V of 0. Obtain the updates from. Check if all the mismatches are below a smaller number. Terminate the process if as, otherwise go back the step 1 to start the next iteration. Formation of the submentions, the Jacobian matrix can simulate by use the active and reactive power equations. The Newton-Raphson flow program is tested on the system data and initial conditions are given. The calculation of the diagonal elements of the matrix J12, we note that the negative of the diagonal elements J21. Therefore, the size of J21, the 3 cross 4 matrices. Therefore, to avoid these discrepancies, we first compute the matrix M and find the power flow analysis, power and reactive power mismatches below 10 to 6. Finally, we are going to the conclusion. Today's electric grid was designed to operate as vertical structure consisting of generation, transmission and distribution and advanced control support devices for reliability, stability and efficiency. Newton-Raphson method can be used to solve the power flow problems to save the stability system with the increasing on the electric network. Newton-Raphson method calculations step by steps minimizing the square sum of discrepancies of nodal capacities during the power flow calculation. The determinant of matrix is positive around 0 and the negative value of the Jacobian matrix determinant. The main properties of Newton-Raphson method are easy to handle PV bus difficulties. The Newton's method in optimization for power flow calculations, the method computational cost on each iteration will be several times greater. Each row of Jacobian matrix corresponding to any bus contains non-zero elements corresponding to all incident buses of the scheme. Thank you. Thank you for watching.